All right, recording. All right, I'm gonna grab my calculator up as well. That's not what I wanted to know. All right, so what we're going to be doing for our last unit is effectively area and volume. The area is super easy. The volume's a little bit harder, so we'll tackle that half before spring break and half afterwards. We will be using integrals throughout this entire thing, so it's kind of an application of integration. That probably makes sense for area between two curves because we've been using integrals to do area. So let's label these pictures, and then we're just going to try a couple of problems so that you get the hang of how to find things. If you like this unit and you are planning on taking BC next year, it gets extended next year, which is pretty exciting. You'll learn new ways to rotate things. So I'm going to label this picture the same way each time. I'm going to label these intersection points A and B. Notice we're now going to be trying to find the area when two curves are interacting with each other, which is kind of different than what we've been doing. Our integral just means area between our curve and the x-axis. So my kind of final goal right now, I'm going to use some colors, is to find this area right here, the area between two of our curves. I don't particularly know how to find that currently, but I'm going to call this function f of x, and this function, kind of the squiggly one, g of x. So you'll notice, assuming g of x is less than f of x on this interval a to b, g of x is below f of x. That's important. All right. One thing we do know how to find is the area between our curve and our x-axis. So I know how to find this. What thing have we been doing that allows us to find the area between a curve and the x-axis? An integral. All right. So I could integrate f of x. Don't give it away. Don't spoil it. All right. What would my bounds be? A and b. All right. I also know how to find the integral between this curve and the x-axis. How could I do that? Integral of g of x, still a and b. Now, if you heard Herbie spoil it, sorry. But if you didn't, let's try to predict. How do you think I would find the green area with the blue and the yellow area? Exactly. So there's a couple of ways to write this. We'll talk about it, and I'm going to give us some pretty consistent verbiage. We can take the a to b of f of x dx and subtract from a to b of g of x dx. A simpler way to write that, though, because we have the difference of two integrals, is just to integrate the difference of the two functions, meaning I could shove these in one integral together. So f of x minus g of x. Now, what that f of x minus g of x, this integrand actually represents, is like the vertical distance between these two curves. So a little bit of a different kind of contextual interpretation, but really the same thing. I'm going to be using very consistent verbiage through this entire unit because we're going to be finding a vertical distance like this a lot. So I will often call this function the top function and this function the bottom function because one is literally higher on the graph and one is literally lower on the graph. There's no like crafty reason I'm using those words. But we're going to be subtracting a top function and a bottom function very frequently. So just that verbiage is what we're going to use. All right, you guys ready to practice this? It's not going to be that thrilling. Apologies. So we're going to start these without the calculator and then kind of roll towards the calculator. Oftentimes this unit, though it's very short and we do it at the end of the year, this unit oftentimes gets a full free response on it. And if we get one, it's usually pretty straightforward. So that's exciting. We're going to start with a couple of questions where we are kind of responsible for graphing ourselves. So these are the types of functions I would be comfortable making you graph without a calculator. Does anyone know what the function y equals x squared looks like? Parabola. Tell me anything you know about it. Goes through the origin. All right. I'm going to just kind of sketch it. That looks good enough. All right. And then what does y equals negative x look like? A line with downward slope. Where does it go through the y-axis? The origin. So I'm just going to kind of draw it like this. I can draw it on the other edge as well. This is telling me I want the area of the region between these two graphs from x equals 0 to x equals 2. So I'm going to kind of go over here and imagine there's kind of a vertical line cutting this off. So I am looking for this area right here. Now, in these questions, it's going to be really important that we draw a picture because an underappreciated part of these problems is making sure you actually know which area you're trying to find. So let's set up an integral, and maybe we'll just integrate one of these by hand just to say we did. So I'm going to set up an integral. What function is our top function? Literally, which function is higher on the graph? X squared. All right, which function is lower on the graph? The bottom function. Negative x. So I'm going to do minus negative x. All right. What do you think my bounds are? 0 and 2. Those are pretty explicit in this question. We'll talk about what happens if they aren't super explicit. You choose the correct ones, but that's fair. All right. Let's integrate literally one of these by hand. What is the integral of x squared? One third. X to the third. All right, I'm going to take this minus and negative and make it a plus. Let's now integrate x. It's a great derivative. 1/2 x squared. Yeah, I think the Friday before spring break, we might just do some multiple choice to reflect. All right. What's that notation that says like, hey, I integrated, but hey, I didn't plug in the bounds? The line and with the 0 and the 2. Now, one of the reasons we're not going to do a ton of these by hand is to make these easy enough to graph. Usually they're not super great to integrate with. So notice all of our fractions here. But let's go ahead and plug in which bound's going in first. 2. So I'm going to have 8/3 plus 4 times 1/2 is 2. Bottom bound, sick. Love a 0 bound. How many thirds are in 2? 8. 6. 6 plus 8 is 14/3. All right. Do you guys agree with 14/3? Our fractions are a little rusty. All right. Now, one thing I'd like to point out. Does it look like I'm counting my area below the x-axis is negative if I am getting the answer 14/3? No. So we are actually talking area here, like full-on area, not the signed area that we did with integrals. So all of the answers that I get in this unit should be what? Positive. So if I got a negative answer, I did something wrong. And that's actually going to be true for this entire unit because we're going to be doing volume as well. So an integral itself will give you positive and negative area. Here, it just says find the area. So we're thinking of like, I fenced in this thing. What's the size of it? All right. Shall we do another one? Let's try. All right. This is the last one we're going to graph on our own. So let's see how creative we can get. What does 2 minus x squared look like? Upside down parabola. Where does it go through the y-axis? Okay. Sketching. All right. We graphed negative x already. That was a line. Went through the origin. Okay. Anyone think they know what area we're looking for? Yeah, this guy right here. All right. This is a phrase we're going to see a lot, the phrase bounded by. What you want to think of is the things that we are bounded by are like a fence. They're fencing in an area, or think of like in this room, we are bounded by the ceiling, the floor, the walls, the door, the windows. What? A fractal? What does that have to do with bounding? You just chucking math words out in the universe? So the bounded by, we need to be completely enclosed by these graphs. All right, so let's try to set up our integral, and maybe I'll have you guys integrate it and find me an answer. What is the top function? Cool, it's literally higher on the graph. What's the bottom function? Negative x. We're subtracting. What are our bounds? So our bounds have to be numbers. So we have to find numbers. What does it look like they are if you had to describe the bounds on the graph? Where they intersect. How could I find that by hand where two graphs intersect? Okay, I could try to reason it out with slope. Algebraically, though, I want those two functions to meet. What can I do to the two functions? I could set them equal to each other. So let's go ahead and take 2 minus x squared and set it equal to negative x. Thoughts on how I can solve this equation? Okay, I can move everything to one side. I'm personally actually going to go the opposite direction because I want a positive x squared. So I'm going to do x squared minus x minus 2. Now what? My Algebra 1 students can do this. They can factor. They just learned how. No. What do we have to multiply to? Yes. All right. So this is x equals 2 and x equals negative 1. That looks like it makes a little bit of sense. This looks like about negative 1. This looks like about 2. Which bound is going to go on top? Which one's going to go on the bottom? Yep, negative 1 up to 2. All right, should we integrate together, or do you think you can handle it? I don't know. All right, let's find out. We rusty. It's okay. All right, I'm going to come back in 4 minutes and ask. You should get a positive answer. You can kind of sense make it by looking at the graph and seeing if the area makes sense. What? It's not that much harder. No. Just has more words. Are you integrating? I am. Fractions, man. What does that mean? Like simplify it? Yeah. So when I say find the area, I mean a number. Because if someone asked you for an area of something and you gave them a function, they'd be a little mad. What is happening? Happens. Oh, there's halves and thirds. Worst. 8. What's that? Minus 1. I don't feel like my answer is right. Yeah. Essentially minus 1/3 because negative 1/3 is negative 30. I don't know. Just checking my answer because I didn't get that, but I don't. That looks good. So where did I make a mistake? Oh, I didn't distribute my negative, did I? Yep, I forgot my negative. That's the negative. Team fractions. All right, let's run through this. It's okay if we're a little rusty. It's been a hot second since we integrated and plugged in some bounds. So our integral, we should have 2x from the 2, negative 1/3 x cubed from the x squared, and then plus 1/2 x squared from the minus negative x. Plugging in the 2 first, I got 4 minus 8/3 plus 2. Plugging in the negative 1, you got negative 2 plus 1/3 plus 1/2. Now, when I'm adding things together, this is just something I've picked up that makes adding fractions easier for me. What I did to get this 8 here was I added up all of the kind of whole numbers here using that minus from the middle as well. Then I added up all the thirds. So that was minus 9/3 from also using this one in the middle. And then I did the halves also using the minus in the middle. I find that usually makes it easier so then I have less terms I have to common denominator. If you hate that method, whatever, use your own. All right, reasons I like my answer. One reason, does anyone know the first reason? What kind of number is that? It's a positive number. So it needs to be a positive number. I did get a positive number. Also, 4.5 kind of sounds like an okay number to me. That area doesn't look super huge, but it's also not super small. I would be concerned if I were getting something like 10,000 or maybe like 0.1. I would also be a little concerned. So you can at least sense make even if your answer is a little bit weird. All right, let's go ahead and let's try out a couple where we're working with the calculator. I'm also going to show you how to do this in terms of y. So the rest of these are pretty much all free response questions that have actually been on AP exams so that we can see what these look like. A lot of the times you're given a graph. So in the next one, you can see they've given you a graph and some information on it. They're telling you R is this region in the first quadrant. It's the one we can see enclosed by these two graphs. So while you don't have to be responsible for graphing them, you will be responsible, since this was a non-calculator question, for knowing which graph is which. So I want you to look at the picture and I want you to decide which one is f of x, which is 8x cubed, and which one is g of x, which is sine of pi x, without putting them in the calculator. I need you to figure out which one is which. I'm going to ask you in a couple of seconds. Is it easy? Good. All right, which one is this one? G of x. Do you guys agree with Xander that this is g of x, the sine of pi x? Perfect. So that makes this bottom one f of x. Perfect. All right. So while you don't need to be super good at graphing, it is helpful to know the basic shapes. So x cubed kind of is has the shape in general of like this. So that's probably why they're choosing this one for f of x. Also, sine, I know, kind of goes up through the origin that way. Anyone else have a reason they chose those, or was that why? That's pretty much why. Yeah, it looks like this. Well, if I could draw this guy. So it's nice to have a good idea of some of the general shapes of our graphs. So what we're going to do for this one is we're going to set it up, and then we're just going to integrate in our calculator to get some practice with that. Most of the questions on your test, if not all of them for this unit 8, will be calculator friendly, or will have the directions to like set up but don't evaluate it. So anyone have an idea of which is the top function and which is the bottom function? G of x is the top function. What will I do to the bottom function? What's going to go in here? Subtract. Now, when you're writing these down, if those functions are labeled f and g, I would encourage you to use that as the notation on your paper. What's glaringly missing from my question? Bounds. What are they? Ooh, is it 0 and 1 or 0 and 1/2? All right. The reason it's 1/2, and we're going to be talking a lot about bounds. Whatever letter is in my integral is the kind of variable I'm using. So I need to make sure if I'm using x's, I need x bounds. Let's go ahead and plug this into our calculator. So I'm going to go, if my calculator will open, to the home screen. Anyone remember where to get an integral on the calculator? Math and then number 9. Perfect. You'll notice the integral, again, has pretty print, which is super easy and super nice. We'll do 1/2 at the top bound. And then I'm going to do, we had g of x minus f of x. So I'm going to do sine of pi x, hopefully your calculator is in radians mode, minus 8x cubed. And I'm going to put dx at the end. Hopefully you get that number. If you don't, check that you're in radians.
I also got that number.
Perfect. Did anyone else get that number, or just me and Herbie?
I got it.
Perfect. All right. What number can I write down on my paper? How many? Yeah, I need 3 decimal places. So I'm going to do 0.193. Keep in mind, since we're going to be doing a lot of these on the calculator, we do want to write our setup. So this guy right here is non-negotiable. We cannot just write down 0.193 without labeling it at all. If we just write a decimal with no work, we get exactly 0 points. All right, so not too bad, right? Let's make it worse. Not really worse, just different. So the cool part about these is I can actually do them in terms of y as well. I'm going to show you that in a second after you guys try to do this one in terms of x. So will you try to set up exactly what we've been doing? I want you to read the question. I want you to try to set up your integral for the area top minus bottom. Just do the whole thing. If you're feeling spicy, even plug it in your calculator. I'm going to give you 3 minutes to try. So right now, I want you to just try to do it in x's. I'm going to show you how to do it in y's. So just set it up exactly like we did before. Just don't use all the room on your paper. Oh no, I knew it. What? What the bound is? Okay, so how far left can I go? If you want, we're gonna do this sometime next class. Sometimes I'll draw this vertical line, especially when we do what we're doing next class. If you draw a vertical line there and kind of slide your pencil back and forth, as long as you're in the region, as far left as you can go, as far right as you can go. Right. Do you guys have it already? And I'm just wasting time? No? Okay. Think you have it? It's okay. We're just learning. Okay. I cannot believe quarter 3 is almost over. Too fast. All right. Is everyone already done? And I'm just wasting time. All right. Any thoughts on your top function? I didn't know what to label it. What is it? So it's what is my integrand, if you will? Allow me to use some vocab. Well, 2 things am I subtracting? 6. Okay. Any thoughts on my bounds? 0 and 9. Good. We're using the x value here because x is in our integral. Did anyone throw this in the calculator? What did you get? Oh, that's your calculator being bad at the answer. What do you think the answer is? 18. Cool. You are. That's just your calculator not actually doing math correctly.
So if you put 17.99
No. They would probably make sure that that error isn't happening on the calculator for the AP test. All right, so let's talk about how to do this in terms of y. So sometimes it's actually beneficial to think, instead of having like this top minus bottom, this kind of vertical distance, sometimes it's helpful to go and think horizontally. Now this one, it's easy enough either way, but it does reorient how we're doing this question. The first thing it reorients is I'm going to need to use y in my integral. So I'm going to have dy at the end, which means I can no longer use this function as it is. I would need to solve it to be in terms of y, meaning I need to get x by itself. So I'm going to divide by 2. Yes, we're learning how to do it a different way so that when we have to do it a different way, we are prepared. How do I get rid of a square root? I square it. So I'd get x equals y squared over 4. So that's what this curve is. But now I also have to reorient my idea of kind of top minus bottom, because I'm now thinking right and left. So if you had to point to one side of the room, top is where the bigger y values are. Where are the bigger x values? They're this way, right? So that function, the y squared over 4, I would argue is kind of the top function. So if you're thinking top minus bottom, this is now more kind of right minus left to make sure I have a positive distance. So I'm going to call the y squared over 4 my top function. What would my bottom function be? How far left can I go? Yeah, this is the line x equals 0. So I can do minus 0. Yes, because they tell me it's in the first quadrant. What are your thoughts on the bounds now? Yep, 0 and 6. I like how you guys notice we're using y in the bounds in the variable. We have to make it all match. Can you throw that one in your calculator and then not be surprised at the result that you get? Should it be? If you throw this in your calculator, once you are in your calculator, you can use whatever letter you want. So if you wanted to not use y, you can use x. That's fine. Once we set up the integral, it's just a variable. Yeah, did this one actually give the right answer? It shouldn't be 9.
Oh my goodness.
What is it?
18?
18. Why am I getting the same answer? It's the same area. I just found it 2 different ways. Okay, but that, again, it's your calculator being bad. What made it do that? Your calculator doesn't actually integrate and plug in the bounds. It uses an approximation technique. So it's actually your calculator being bad at math. All right. So kind of going back to Satya's question, why would I ever do this? I have the answer one way. Why would I do it a different way? So looking at this one, if I tried to do this one in terms of X, so thinking vertically, thinking going from here all the way over to here, I got some problems. I have a consistent top and bottom function all the way to this point right here. But then the top and bottom function is the same function. It also changes. That's super awkward and weird. But if I think horizontally, no matter where I put this pink line within this region, there is a consistent function that's to the right and a consistent function that's to the left. Can anyone else see something about the question that might make me want to work in terms of y? Yeah, look at these functions. They're like, hey, you know what might be a good idea? Just thinking. So they're trying to help you out with that. Can anyone tell which function is which? Does anyone know which one the x equals 3 minus y squared is? The red one, the parabola. And then this guy is the x equals y plus 1. So I could do this both ways, but this way with y is a heck of a lot easier. So let's try to set it up. Which function would come first in our subtraction? Which one is the top function? The one with the bigger x values. 3 minus y squared. Yes.
If you don't know which one is which, can you do the math twice, but with them switched?
You could try. What do you think would happen if I subtracted the wrong way? Yeah, it would be negative. It would be exactly the right number, but it would be negative. So if you do it one way, you probably have the right answer if you get the negative one. You just have to flip them. And a really easy way to flip them notationally, here's me being really lazy. Say I get the wrong answer, do this. All right, I'm going to make this dy. Notice I am using parentheses around the back end. That's really important when we subtract. Any thoughts on the bounds? -1 to 3 would be great x bounds. It would be lovely x bounds. We are not working in terms of x. -2 up to 1. Can you remind me, just in case I didn't have this well labeled of a graph, how could I find those if I had to do it with algebra? How did we do it before? I could set them equal to each other. All right, let's just practice plugging this into the calculator. Can you all plug it in? I'll plug it in. We'll make sure we get the right answer. This is one I would feel relatively comfortable putting on a test for you to integrate. It does have quite a few fractions and multiple types of bounds, which is a little bit annoying. Again, when you plug this in on the calculator, even though you have y as your letter, you can certainly use x when you integrate on the calculator. Did we get the same answer as something we did before? If you guys are getting 2.6, I bet I know what you're doing. Nope, no, I don't. Did anyone get something slightly north of 4? Yeah. All right, you should be getting 4.5 or 9/2. I'll do both to satisfy some of our class members. Again, I like that answer. It's positive, not too big, not too small. We're all right. All right, I'd like to finish out our questioning with this one's definitely been on an AP exam, and it's definitely been on the calculator part. Look at these functions. Wow. They're wild. So what I'm going to do first, and I'm going to do this actually on the board this time, on the board calculator. If you see a free response, it's talking about area and volume, you're probably going to use these functions multiple times. So the very first thing I'm going to do is I'm going to go and I'm going to put these two functions in y equals so I can use them in multiple parts of this question. So will you also go and put f of x in y1 and g of x in y2? Yes, E is down above the one that says LN. It's like over 2 buttons up from on. So you're going to press second and then that button and you'll get your E.
Is it possible to get this question?
Not with these functions, no. With these functions, this question is literally, you cannot do it without a calculator. Oop. Yeah, so when we do calculator questions, it's not like the SAT where it's like, it's okay if you don't have a calculator, it's just inconvenient. No, you cannot do them. Oh, darn it. Just a hint, if you ever forget a plus sign or a minus sign like I just did, if you press second and then delete for the INS, that's insert. So you don't have to clear out the whole thing. Cool. So I'm actually going to show you how to do this question 2 ways. First thing, I clicked on graph just to make sure I kind of had the right 2 graphs there. It looks pretty similar to the picture. I'm not going to deal with the window because they already gave me a picture. Let's look at the picture though and kind of label a little bit. So I heard Daniel kind of remarking about which graph was which. This blue graph right here is that E graph, and then the red graph, that kind of more curvy one, is the x to the 4th graph. What do you notice is slightly different about this question than the questions we've been doing so far? I know it's a very vague question, but yeah, they switch which function is the top function and which one is the bottom function. That is definitely one way to do it. So what Derek said is, would you do them separately and add them together? Absolutely. And that's the way I would want to do this question if I did not have a calculator. Now, one thing I noticed about this picture, and I'm going to show you another way to do it. We'll talk it through then. One thing I noticed about this picture, if I'm splitting this into 2 integrals, I need to know where this point is. Where do you think it is? In between. Do you think you know exactly what number? No, because they didn't label it. How many people do you think said it was 1? A lot. And they were all wrong because it's not exactly 1. So we're going to find it. We're going to label it. We're going to store it even. It'll be fun. Anyone remember how to find an intersection on this graph? Yep, we're going to do second trace actually to get to this menu. So you don't want to just trace close. We want to get exactly. Which one am I going to choose? 5. Your calculator is going to ask you 3 questions. The first 2 should be just generic. It's going to ask you which 2 curves. I only have 2 curves graph, so I can just press enter and enter. This question is important. It says guess. I need to make sure I'm closest to that middle intersection point than any of the other points on the graphs where they intersect. If you want, you can just scroll close, or we said 1 was pretty close, so you could press 1 and enter, or scroll close and hit enter. Either one is fine. It is a funky number. So it is 1.032831.9. I'm going to write that down, and I immediately forgot it. 1.0328319. All right. Did you do second intersect like we did with the? Ooh. Can you check that you plugged in your functions correctly? And then maybe we'll try again. All right. So if you need the steps again, we're doing second trace number 5. Enter, enter. Make sure you're closest to that intersection point. Enter again. All right.
You like this.
All right. So let's talk about this guy. All right, option 1, you can use that entire decimal every time you use that bound. Is anyone not wanting to use that entire decimal every time they plug it into the calculator? Cool. Then what you can do is you can go back to the home screen and store that value in your calculator. So what I pressed the letter X. That's going to pull the X value I currently have on my graph. So, which is this bottom button right here, right above on, that's stow for store. And then I did alpha A. That will put that value in your calculator until you physically go in and change the letter A. If you press enter, that number should come up from your graph. This is an optional step, but it will help you because then you won't have to retype this number every time. What you want to avoid is rounding this number before you use it in your bound. Odds are that that will make your final answer not the right answer. Yep, so now every time I hit A, it will plug in that number, but it'll even do like math with that. Okay, let's go ahead and go back to our graph. We're gonna find the intersection again. We have to make sure we're not doing anything between our intersection and then when we go and do that on the home screen. That's a good question. So I did, as soon as I was done finding the intersection without changing anything, I went second quit back to this home screen. I did the letter X from the top, stow, which is right above on, and then alpha A, it's right above math, and pressed enter. If you've moved your graph at all, though, it's taking the current X value, so you have to make sure you do it right after you find the intersection. Now, Derek asked a really good question of, can I use A on my paper? As long as you label it, absolutely. So that's why I went and on my graph, I called it A, so that now when I write this down, I can use A as well. Yep, you're fine. All right. So you've got your intersection. You haven't moved your graph. All right. All right. So on your graph, you've got, I'm just going to make sure mine's in the right place. I did the intersection, enter, enter, enter. Second trace. 5, enter, enter, get closest, enter. All right, second trace 5. Enter, enter. Now, guess you either have to guess the number that's closest, so you could say 1, enter, or notice how my little clicker is closest to that intersection point than any other intersection point. If that's true, you can just press enter. When you have it, it should say intersection and then what? 1.0328319. All right, now hit second quit. You're gonna put X, store, which is right above on, alpha, whatever letter I'm using A. So the cool part about this is I can now make it do math with this, whatever I want. Yeah. Yep, so if you have multiple intersection points or multiple things you wanted to store, absolutely. All right, so let's go ahead and set it up the way that Derek said by setting up 2 integrals. So we're going to look at R first. Excuse me. Did not ask you to do that. All right, let's start with R. What will my integrand be? What 2 functions will I be subtracting and in what order? Yep, which way will I be subtracting? Am I looking at it right? G minus F. All right, G of X minus F of X. All right, my bounds for region R will be what? Yeah, 0 to my decimal. If I have labeled on my paper that that is A, I can use the letter A. Benefit. All right, now I'm going to add on, think the letter or the word sum. I'm going to be adding on the area for S. What's going to change? All right, A to 2, my bounds will change. What else? F of X minus G of X. I'm going to show you a separate way where you can. All right. So Herbie's asking a really good question. Why can't I just go from 0 to 2? Well, the direction of my subtraction is definitely going to matter here, right? One time F is on top, other time G is on top. So it does matter which way I'm subtracting. What did we say would happen to the answer if I subtracted the wrong way? It'll just make it negative. Is there a function that you guys know of that'll take negative things and make them positive? Alternative way to do this, the way to make it subtract the right way every time, is to just absolute value. Then you can do f of x minus g of x. You could do g of x minus f of x. And you can go all the way from 0 to 2. So these are two alternative options. Now, you might say, why wouldn't I do option 2 every single time? That seems easier. Absolute value does not play well with calculus and like integrating by hand. So this would only work if you have a calculator. That being said, you're going to have a calculator most of the time for these questions, especially with terrible functions like this. So there we go. The last thing I want to show you is how to plug this into the calculator. I'm going to do both of them just to check to make sure that this is working fine. So for the first one, I'm going to go math 9, 0 up to alpha A. Now, I don't want to type those functions in again, so I'm going to use, have we done alpha trace in this class? All right, so I'm going to reference these. I'm going to alpha trace, and the first one was G minus F. So I'm actually going to go Y2 minus Y1. Alpha trace. And then I'm going to add on math 9 from alpha A up to 2. Alpha trace Y1 minus alpha trace Y2. I would highly recommend using that calculator trick, especially given how crazy these functions are. You should be getting something ever so slightly north of 2. What? No, this one's actually 2.004. All right. If you want to check that this is the same both ways, I can go math 9 from 0 all the way up to 2. Anyone remember where the absolute value bars are? Perfect. All right. And then it literally doesn't matter which way I subtract. So I'm going to just do Y1 minus Y2. The absolute value is going to make sure I subtract the right way every single time. And notice I do get the same number. Now it is a little bit different at the end, and that's because your calculator is approximating when it does an integral. So they would make sure on the AP writer side that this would be giving you the right answer. So you don't have to worry about it. All right. I can be done. We don't need to do the last question. All right, so I do want to show you, before I give you all of the time in the world to finish your problem set, I'm going to kind of pull up a Desmos graph real quick to show you the next two things we're going to do. Because in a couple of words, the rest of our Unit 8 is, in a couple words, visually stunning. So let's see. Next class, we'll be doing what's called volume with cross sections. So we're going to take, so we're going to be finding volume. So it'll be 3D. So we're going to take a region in the XY plane like this, and we're going to build up cross sections on it. What shape does it look like I'm pulling there? Squares, but I can do other shapes. Where is I never remember where this thing is. It's an input. Nope, it's not there. Here we go. So I can do triangles. I can do semicircles. We're not going to do pentagons, but you certainly could. Circles we're also going to rotate. So 8.3 is, where's my graph? Solids of rotation. So where's my rotate? Rotate. Nope, wrong one. Where is it? A is, hold on. A is, here we go, revolution. So this one will be rotating around. So we'll see some circles there. Okay, so that's kind of the end of our year is we're going to be looking at volume. All three of those together will make up our last test of the year. We only have one more besides the one you're going to be taking next class. All right. That's all I've got for you today. So what I'm going to do now is let you work on your problem sets. I'll be rolling around with my answer key. So if you have any questions, concerns, comments, let me know.